Hello, this is going to be 6th grade worksheet for October 14th on today. Let's zoom in a little bit more. So it says find the sum of following fractions and simplify. So let's do a simple one right off the bat. 2 sevenths plus 3 sevenths, that's just going to be add the numerators, and the denominators are already the same, so it's just going to be 5 over 7. Let's try one a little bit more difficult, like this one. 5 ninths plus 3 eighths. Well, it's kind of, there's no common factors between here and here, right? So we just multiply this times this, so 5 over 9 times 8 over 8 plus 3 over 8 times 9 over 9, because you can only multiply by 1 because of the identity property of multiplication. So that's 40 over 72 plus 27 over 72. Add those and you get 67 over 72. Let's go over another one that does have like factors. So let's check out this one. 5 6 plus 6 twelfths. Well, it can be kind of simplified. So both of them have the common factor 6, right? 12 can just stay the same. 6 just needs to become 12. So you get 5 over 6 times 2 over 2 plus 6 over 12. Well, 5 times 2 is 10. 10 plus 6, 16 over 12. If you want to simplify further from here, then you can just go like boop. And you can get like 4 over 3. Yeah. Second page. So we're going to be multiplying fractions by whole numbers. Well, this is really simple when you start to think of whole numbers as just the number. For instance, like 3 just over 1. That's the general concept that we'll be pushing through out here, okay? Let's go over something super simple, like number 2. Let's put this over 1, and it's just regular multiplication of fractions. So 11 times 2, 1 times 7, it's going to be 22 over 7. Since it wants it to simplify, I guess we can put it into mixed number. So you can factor out 21, so that becomes 3 times 1 over 7. That's another answer. You can leave it in either way. Let's go over a different one. Hey, this one seems interesting. So 8 times 4 over 8. This is really cool because once you do 8 over 1, then you multiply 32 over 8. Then you end up getting, then you can factor it out. 1. 4 over 1. Like we said, anything over 1 is itself, except in integer form, so it's going to be 4. The last problem we'll be going over is right here, 2 times 3 over 5. So we're just going to do the exact same thing. 2 over 1 times 3 over 5. Multiply these two, get 6 over 5. Alright, the next page is going to be about measuring angles. So, let's look at a couple, let's draw something. So, this is 90 degrees, right? You guys learned this, 90 degrees. So this is a right angle. It's a right angle right here. Anything bigger than this, so like this, is going to be an obtuse angle. Anything smaller, like this, is going to be an acute angle. In terms of numbers, what does that mean? That means this is going to be like 20. This is going to be less than 90. This number is going to be greater than 90, like 110. That's all you have to, that's what you have to know when going into here. Alright, 45-degree right angle. Well, 45-degree acute angle. Sorry, I read that wrong. So you see this is about half. Because 45 is half of 90, right? So this would be a right angle. And half of a right angle is the acute angle. Is 45 degrees. Anyway, let's go over a couple questions then. Okay, so for number 1, we have to find from this list. Does this look bigger or smaller than a right angle, or does it look like a right angle? Kind of looks a little bit smaller, right? A right angle would be kind of like that. Yeah. So since it's a little bit smaller, it's not going to be 90 degrees. It's going to be a little less than 90 degrees. Let's look over here. 45 degrees, that's a little bit too short for what we had, right? 35 degrees, that's even less. So let's just go with 80. 80, and since it's less than 90 degrees, acute angle. Let's just go over this one. This one looks weird because it's flipped vertically. But what doesn't change is that this is the angle. And honestly, we can just draw like the 90 degree right here for comparison. Wow, it's almost double the size. It's almost a straight line, you know? So, let's check it out. Almost a straight line. What does that look like? Either 170 or 155. Say that's 170. Let's just say that was 170 since it looks really close to 180, right? So 170 degrees. And if you want, you can use a protractor. I don't have one with me right now, but if you want, you can use a protractor and actually check yourself. That looks like I typed, that looks like I wrote no, but it's actually 170. As this is greater than 90, it's going to be obtuse. Alright, on to the next page. Car travels 120 miles in 3 hours with constant speed. How far will it take to travel 200 miles? So, let's write out some facts. 120 miles in 3 hours. So once we convert that, what do we want to do here? And we have to find what 200 miles is. We can, let's do the easy way here and find the miles per hour and then apply it to here, okay? So miles per hour. Miles per hour. So 120 miles in 3 hours. That's just dividing, right? Comes 40 miles per hour. Well, 40 miles an hour. How long does it take to go 200? So that's just 200 divided by 40 to get the amount of hours. And that'll be 5 hours. 5 hours. Because the speed is 40 miles per hour, and to go 200 miles, you need 5 hours. 50 let's go over number 4. 13 candy bars weigh 26 ounces. What's the weight of 35 candy bars? Well, let's find out how much one candy bar weighs, right? So you get 26 ounces. That's the weight. We're trying to find weight per candy bar, okay? Ounces per candy bar. 26 ounces. I'm just gonna write ounces over 13 candy bars. Right, we're trying to find the ounces per candy bar. Ounces for each candy bar. That's what per means. So, like miles per hour, so it's like miles for each hour. Anyway, you cancel this out, you divide it, you get 2 ounces for each candy bar. But if you have 35 of those, there's going to be 2 times 35, it's going to be 70. Ounces can be written, oh shit, my bad. Ounces can be written as OZs, for short. And thank you. That's gonna be it. Took 10 minutes.